Order of operations is another of my favorite things. It's so critical when you're solving equations and simplifying expressions. It's so frustrating for people who know how to do the more difficult work but make mistakes in their order of operations. Don't let it happen to you. All right, so here we have two possibilities for doing the expression 12 plus 3 times 4. We have two options. We could multiply first, or we could do the addition first. Is one of them better than the other? Not necessarily, but we had to choose one because it's not going to work out if half the people are getting one answer and the other half of the people are getting a different answer. So we just had to agree to always do the order of operations the same way. And the correct method is this one. We want to do multiplying before adding. And the main idea is that you do the stronger operations first, whatever's going to have more effect. And multiplying changes numbers more than adding does. And the entire rundown is given by the acronym PEMDAS. It's an easy way to remember which operations you do first. The first thing is parentheses. That's kind of like a workaround. If you don't like the regular order of operations, put in some parentheses, and that's like saying, I'd rather do this first. And aside from parentheses, the first thing you do is exponents. Then you multiply and divide from left to right. This is really important. A lot of times people think that because the M comes before the D in PEMDAS, that you need to multiply first. But the M and the D are really on equal footing. In fact, in Britain, instead of PEMDAS, they say BODMAS. And you can see they've switched the M and the D. So the order doesn't matter. You just want to do those from left to right. And then the last thing, once everything else is gone, you do any adding and subtracting. Sometimes people say you have to go from left to right, but that's not true. You can do it in any order you want. Let's do an example. I tried to pick examples that people often make mistakes on. And can you see what mistake somebody might make here? It's really tempting for people to want to do that initial subtraction first and subtract the 9 times the 2. But that is not correct because we want to do subtraction last. This 2 here needs to get multiplied by everything that's inside those brackets. So we're just going to keep writing this 9 here every time until the last step when it's time to add it in. Now, I know that people want to save work and save paper, but it's absolutely critical that you write down every step, at least while you're learning. If you try and do it in your head, you're going to make mistakes. And I know because I see it happening all the time. So I'm going to start inside my brackets here with the parentheses. Now, inside each set of parentheses, you apply another PEMDAS. So the first thing inside the parentheses here that I need to do is 7 squared. Now, notice that it's subtracting 7 squared. So I'm going to be subtracting 49. The squared does not apply to the negative in this case. And then 3 times 5 is 15. I can do that subtraction because it's in parentheses by itself, but I'm just going to save it for the next line. Now, in this case, the negative 3 is inside the parentheses. The negative is in there going with the 3. So you're going to square negative 3, and that's going to give you a positive 9. Great. So now I have 9 minus 2 times, let's see, 15 minus 49. I think that's negative 34. And then we'll add 9 to it. So now we have 9 minus 2 times, let's say, negative 25. And now we multiply. Remember, brackets and parentheses indicate multiplication. So I have 9 minus, or maybe it's going to be plus. Negative 2 times negative 25 is 50. And so our final answer is 59. I'd like to reiterate the situation with squaring numbers that have minuses in front of them. Remember, if the number is inside parentheses with the negative sign, you square the negative and you get a positive result. But if the negative is not inside parentheses, that means I'm only squaring the 3. I'm not squaring the negative, so I end up with a -9. I can't tell you how many times I've seen people get problems wrong because of this mistake. It's really worth your time to put a lot of effort into remembering this distinction. Okay, here's an example that's very similar to the one we just did, but I made some changes. Remember last time I said it was critical that we did not do the subtraction first, but here we have parentheses around the subtraction, and those are in there to say, no, I want you to do that first. So I will. 9 minus 11 is -2. Ah, there's that -2 again. Okay, now the -10 squared is in parentheses, so I'm going to multiply -10 times -10 and get positive 100. That's going to be multiplied by 2. Now here's another case where I have a negative being squared inside the parentheses. So that's going to be 25 multiplied by the 6. Now be careful here. It's not going to turn into plus 100. I'm subtracting the 10 squared, which means I'm subtracting 100. And then 3 times 5 is 15. So now I have all these little addition chunks. Well, I have terms that are chunked up by pluses and minuses. So I'll go through and do all those multiplications and then add the numbers up. So I get 200 plus 150 minus 100 plus 15. And like I said, you can go in any order when you're doing the addition and subtraction. Maybe I want to say 200 minus 100 is 100, and then plus 150 is 250, and plus 15 is 265. So I've got -2 times 265. If you want, you can switch from square brackets to parentheses once you only have one set, but it doesn't matter. And so -2 times 265 is -530, and there's our answer.